Hello dear student, myself Prof. Sukhbir K. Today we learn new chapter Rotational Dynamics. In this chapter we can discuss one by one concepts. Firstly we discuss introductory part, then we discuss what is the actual definition of a rotational dynamics, then we discuss what I mean by circular motion, then we discuss characteristic of circular motion, and this circular motion can be classified into two types. First is uniform circular motion, another type is a non-uniform circular motion. These all concepts we can discuss one by one here. Firstly, we discuss here what is the difference between revolution and rotation of an object. What do you mean by revolution? During revolution, the objects means every particle in objects undergoes circular motion about some point outside the objects or about some other objects. This is called as a revolution. And what is meant by rotation? During rotation, the motion is about an axis of rotation passing through the objects. During rotation, the motion is about an axis of rotation passing through the object. This is the basic difference between revolution and rotation of an object. In this chapter, we can firstly discuss what I mean by rotational dynamics. Firstly, definition of a rotational dynamics. Rotational dynamics is the study of forces and the motion about an axis of rotation. Rotational dynamics is the study of forces and the motion about an axis of rotation. Then next question is what do you mean by axis of rotation? Definition: the center of all circle lie along a straight line is called as a axis of rotation. Then we can discuss next definition is a circular motion. What do you mean by circular motion? Definition: motion of an object along the circumference of a circle is called as a circular motion. Motion of an object along the circumference of a circle is called as a circular motion. Some example given here. What is a example of a circular motion? First one is a motion of earth around the sun. This is the best example of a circular motion. Another example, motion of planet around the sun. Third example, motion of the tip of the blades of the fans. And fourth one, motion of the swing or chair of merry-go-rounds. These all example of a circular motion. I am repeat here what I mean by circular definition of a circular motion. Motion of an object along the circumference of a circle is called as a circular motion. Then we discuss next point here, characteristic of a circular motion. Characteristic of a circular motion. Some question asked on this topic. State the characteristic of a circular motion. First characteristic is it is an accelerated motion. Circular motion is called as an accelerated motion because as the direction of velocity changes at every instant, it is an accelerated motion. Second characteristic of a circular motion is it is periodic motion. What do you mean by periodic motion? During the motion, the particle repeat its path along the same trajectory. Thus, the motion is a periodic. Hence, circular motion is called as a periodic motion. This is a two characteristic of a circular motion. First one is it is an accelerated motion. and second one, it is a periodic motion. Then we can discuss the next point here. uh, Next point here, kinematic of a circular motion. What is a kinematic of a circular motion? In circular motion we use the quantity angular displacement. This angular displacement we can denote here theta. Then angular velocity means what? Angular velocity means what? We can write formula, angular velocity denoted by omega, and theta with the angular displacement. Then angular velocity means what? The rate of change of angular displacement with respect to time is called as a angular velocity. Then we can write here omega is equal to d theta upon dt. Then another concept we can written here, angular acceleration. What do you mean by angular acceleration? Given formula, this angular acceleration we can write here alpha bar, and omega is the angular velocity. According to this formula we can derive the definition of angular acceleration. Angular velocity, the rate of change of angular velocity with respect to time is called as a angular acceleration. uh, uh, we can derive here angular velocity omega is equal to d theta upon dt, and angular acceleration is alpha bar is equal to d omega upon dt, which are analogous to displacement s bar. Then linear velocity we can write here linear velocity denoted by v bar, and displacement denoted by s bar. Then we can write linear velocity v bar is equal to ds bar upon dt. The rate of change of displacement upon time is called as a linear velocity, and linear acceleration denoted by a bars. Then definition of a linear acceleration, the rate of change of linear velocity with respect to time is called as a linear acceleration. Used in the translational, these two formula used in the translational motion. Second one, the tangential velocity is given by v bar is equal to omega bar into r bar, where v bar is the angular velocity and r bar be the radius vector from the center of the circular motion. Then we can calculate here magnitude of linear velocity. Then we can write here third points, the magnitude of v bar is given by v is equal to omega into r, omega into r. Fourth one, the direction of omega is always along the axis of rotation and is given by right hand thumb rule. Direction of omega, that is a angular velocity, is always along the axis of rotation and is given by the right hand thumb rule. We can find direction of a angular velocity. To know the direction of omega, the curl finger gives the direction of a motion of particle performing circular motion. Then outstretched thumb gives the direction of a angular velocity. See this diagram, we can find here direction of a angular velocity when this particle performing circular motion in a anticlockwise sense. Then direction of this angular velocity gives here in this way, and when particle performing circular motion is clockwise sense, then direction of a angular velocity gives in this direction. This direction. Then next point we can consider here in kinematics of a circular motion. How is angular velocity related with the periodic time and frequency? If capital T is a periodic time and small n is a frequency, then omega is equal to 2 pi n. But here frequency means what? The reciprocal of period. We can write this omega is equal to 2 pi upon t because n is equal to 1 upon t, because frequency is reciprocal of period, then omega is equal to 2 pi upon t. Then we can explain the term circular motion, uniform circular motion and non-uniform circular motion. Definition: uniform circular motion and non-uniform circular motion. Firstly, we discuss what I mean by uniform circular motion. Definition: uniform circular motion can be defined as the motion of a particle along circumference of a circle with a constant speed. Definition: we can prepare here what I mean by uniform circular motion. Uniform circular motion can be defined as the motion of particle along the circumference of a circle with a constant speed. Another definition we can given here what is by uniform circular motion. Uniform circular motion can be defined as the motion of particle along the circumference of a circle with a constant linear speed, and angular velocity. This is another definition of a uniform circular motion. We given some characteristic of a uniform circular motion. Firstly, discuss here. First characteristic: the linear speed of a particle remain constant. In a uniform circular motion, linear speed of particle remain constant. Second characteristic: the linear velocity of the particle changes due to change in direction. When direction is changed, then the linear velocity of particle also changes here. And third characteristic: direction of a linear velocity is along the tangent to the circular path. The direction of a linear velocity is along the tangent to the circular path. Fourth one: linear velocity of the particle changes, thus uniform circular motion is an accelerated motion. Uniform circular motion is also called as a accelerated motion because the linear velocity of the particle changes. Hence, this uniform circular motion is called as an accelerated motion. Fifth characteristic: the angular velocity of a particle remain constant. Hence, angular acceleration is 0. Angular acceleration is 0 because the angular velocity of particle remain constant. Hence, angular acceleration is a 0. And sixth number, angular acceleration is 0. Hence, tangential acceleration 0. In a uniform circular motion, angular acceleration is 0 because angular velocity of a particle remain constant. Hence, angular acceleration is 0. Corresponding tangential acceleration is 0. And another characteristic, UCM, that is a uniform circular motion, is a periodic motion. Uniform circular motion is a periodic motion. For example of a uniform circular motion, first example is a motion of the tip of hand of a clock, and second example, motion of the earth around the sun. This is the best example of a uniform circular motion. Another type of a circular motion is non-uniform circular motion. Definition: non-uniform circular motion can be defined as the motion of the particle along the circumference of a circle with changes. Non-uniform circular motion can be defined as the motion of the particle along the circumference of a circle with changes. Example of a non-uniform circular motion we can given here. First example is in a roller coaster, cars slow down and speed up as it move around a vertical loops. This is the best example of a non-uniform circular motion. Second one is when fan is switch on or off, the speed of particles of a fan goes on increases or decreasing for some time. However, their direction are always tangential to their circular trajectory. In this way, we can discuss what I mean by uniform circular motion, what I mean by non-uniform circular motion. Some question asked on these topics. First, what is the distinguish between uniform circular motion and non-uniform circular motion? Distinguish between uniform circular motion or non-uniform circular motion. In a uniform circular motion, speed remain constant. In uniform circular motion, speed is constant, and in a non-uniform circular motion, speed is not constant. Speed is changeable or changes. Second difference: a radial component of acceleration is constant. In a non-uniform circular motion, there is a component of acceleration is not constant here. Third points: there is a no component of an acceleration along the tangents, and in a non-uniform circular motion, there is a component of a acceleration along the tangent. And the next one, in uniform circular motion, kinetic energy and potential energy is always constant at every point of a circumference, and non-uniform circular motion, in a non-uniform circular motion, kinetic energy and potential energy changes at every point of the circumference. In this way, we can distinguish between what I mean by uniform circular motion and non-uniform circular motion. In this way, we can discuss introductory part in the rotational dynamics. Firstly, we discuss what I mean by rotational dynamics. Then we can discuss axis of rotation. Another concept we can discuss here, what I mean by circular motion. Then we give here some best example of a circular motion, and another concept we can discuss here, characteristic of a circular motion. First one is it is an accelerated motion. Another type is it is a periodic motion. Then we can discuss kinematic of a circular motion. In kinematic of circular motion, we can discuss uh, in a translational motion and kinematic translational motion and rotational motion. These two concepts we can discuss here, and mostly Important point we can discuss here: uniform circular motion and non-uniform circular motion. Today we stop here. Thank you.